Okay, so we are live. Hi everyone, and very good evening, and welcome back to Geeks for Geeks. Please, if you have joined, so please give me a +1 in the chat, and let me check if my voice is uh, clearly audible or not. So, what would be the approach for the second problem? Yeah, I'll tell you about all the approaches for the problem. Second problem was uh, quite easy. It just was based on mapping only. So I get the problem. I guess the problem setter had some obsession uh, with the approach of hash map, because first two problems were based on hash maps only, right? So yes, you can react a thumbs up guys in the chat if everything is working fine, and you can hit the like button as well, so that we can get started. Now I'll quickly share my screen so that we can discuss the problems as well. I hope that my screen is getting shared properly, right? Okay, so let's get started with the problems. Now, discussing the very first problem, that is find word. Now, it was quite easy. The problem says that you will be given a dictionary. Okay, dictionary of length n will be given. So, in the first problem, that is first word. Okay, in this problem, a dictionary is given. Basically, a array of string is given. Okay, so you can see that we'll be given what? We'll be given geeks for geeks, let's say. For the first test case, we are given geeks for geeks. Then after that, we are given geeks also, and then we are given what? Then we are given geek. Okay, so these are the three strings that are given to you. Now what you have to do is when you are given the dictionary, so you have to do two things. Okay, first of all, you have to apply one check, that if a word is repeating in the dictionary, then you have to return invalid. Okay, then you have to return the message invalid. Otherwise, if all the words are unique, then you have to return the smaller, then you have to return the alphabetically smallest word. For example, if you will see here now, so amongst these given words, right, alphabetically the smallest word is basically geek, because every other word also has got geek, right? All the words have got the prefix as geek, but geeks for geeks is large. Okay, then geeks is large and geek is the smallest. So alphabetically it will be counted as the smallest. It will be considered as the smallest. That is why geek was the answer. So basically what you can do is that you can iterate throughout this particular given dictionary. Okay, and then what you can do is you can keep a track of the minimum word. So in C++ you can directly keep a track of minimum. I'll tell you how. Okay, now for the second test case, if you'll observe, let's say if I was given what, if I was given something like let's say geek, and then I was given what, I hope that everything is working fine in the chat. Okay, then after that I was given geek again. So what will happen is, now when I come across this geek word, I'll put it inside the map. Okay, inside the map, let's say we'll mark the geek as true. Okay, then later on when you come to this particular word again, okay, so you check that is this word present in the map? Yes, it is present. If a word is present repetitively or duplicate number of times, then you need to return the message as invalid. Okay, does this make sense? Solve the first problem in 2 minutes and write for the next problem 1 hour 28 minutes. But I feel the third problem was hard. Fourth problem was based on recursion. So if you have very good idea about recursion, then it's easy. Okay, so is the approach clear for the first problem for everyone? You can tell me in the chat, guys. Does the approach completely make sense or not? If it does, then you can quickly tell me. Right, Abhishek Mittal as well. Right, so see, what you will do is you can declare a map basically. Okay, so first of all, I can declare a map. Right, I will be storing the strings as the keys. Okay, because I have to check for repeated strings. Now I'll be storing boolean. If they are present, I'll keep on marking them as true. Also, one more thing I need to consider, that I need to keep a track of the smallest string. Okay, in the given dictionary. So then in the list of strings, that is the dictionary. Now initially I'll mark my answer as the very first word, that is dictionary of 0. Then after that, what you need to do is you need to mark the 0th character, zeroth string as 1. Indirectly you're marking it as present in the map. Then you start your from index 1 till the end of the array, and then what you can do is you can check that if the current ith word that you are at, if that word is what, if that word is yeah, that can be solved using sorting also, but assuming that you have to solve it in order of n time na, then sorting is not a good option. So you can see here that if the word, if the current ith word that I'm at, if it is present inside the dictionary, then I'll do what? I'll directly return the message as invalid. Otherwise, what I'll do is, otherwise I will simply first of all I'll store like update this particular word inside the map, so that next time I can find it. And since I was at this ith word, so I'll keep a track of the minimum word. Okay, so in other languages you might have to use compare functions, but in C++ I can just find the minimum just by using the min function. Okay, so it helps me to take this minimum function helps me to find minimum for strings as well as integers and anything, and then at the end we return the answer. So if this is clear, you can tell me. Basic recursion was giving clearly because of contest pressure, dp was not working. Okay, right. So if this much is clear, you can definitely react thumbs up to this stream. Okay, I hope that this question is clear so far. Now what happens is, coming to the next problem, that is the second problem for this contest. Now second problem was quite interesting as well. Now when it comes to the second problem, so basically talking about the second problem, and for the first problem, the time complexity taken by my code would be order of n, and the space complexity taken would be order of n as well, because we are using extra map data structure here. Correct. So this is the time and the space complexity for our codes. Now what happens is, next up when we will move forward, okay, so what will happen is, if you have this question that is sum uh, equals length. Okay, the next question is sum uh, equals length. So basically for doing this, if you want that you can solve such kind of problems very easily. So there are several problems which you should be knowing. Basically one of the problems now that you could have done is sub array with zero sum. Okay, sub array, like basically check sub array with zero sum. These are some of the problems which you need to try out after this problem if you haven't tried this them out. Okay, so check if subarray with zero sum exists. Check if subarray with zero sum exists. Okay, with zero sum exist. Okay, this basically you have to check whether subarray is there in the array which is having zero sum or not. Okay, then there's another problem, that is count subarray with zero sum. Okay, count sub. The reason why I'm telling this is because when you solve a contest, so not only you want to get the solution for this problem, or you want to understand how it will be solved if you are not able to solve, but also you should see the derivative or the standard problems that are kind of similar, and they use the hash map approach. Then checking subarray with k sum. Okay, check subarray with k sum problem also, subarray with k sum. Then another problem is count subarray with k sum. Right, count subarray with k sum. All these problems that are there, these problems can if you have solved these problems, then this problem would have been very easy. If you agree, you can tell me. Right, so now coming to this problem once again. Right, so in this particular problem it says that you'll be given an array. Okay, and the problem is to find the length of what? The length of the longest subarray, such that the sum of the subarray is equal to the length of the subarray. So basically the thing is that in this particular problem, if you'll observe, let's say if I have got this particular array here. Okay, and the array is what? The array is basically 16. Then we have got -1. Then we have got what? We have got 3. Then we have got -7. Okay, then we have got 2. Okay, then we have got what? We have got 8 here. Then we have got what? We have got 11. Then we have got 24. So let's say this is the array that you have. Now basically you have to find the length of the you have to find the length of the longest subarray, such that the sum of that subarray is equal to the length of the subarray. So basically if you'll observe, so in this particular case, this particular array that is there, okay, the sum of this array is how much? You can see that -7 and -1 plus 8 will be 0, and 3 plus 2 will be 5. So basically the sum for this particular subarray comes out to be 5, and the length for this particular subarray is also 5, right? So we need to iterate, and we need to use a hash map approach, because as I said already, if you want to solve such kind of problems, prerequisite is that you should have solved problems like checking subarray with zero sum, counting subarray with zero sum, checking subarray with k sum. Okay, if you have solved such problems, then it's quite easy. Now what you will do is, like basically this kind of problem can be solved using the hashing approach, because what you can do is you have to check whether a sum that you have whether a particular prefix sum that you have calculated already, if it is present again or not. Okay, so in this case, now what will happen is, First of all, we will do what? We will have a map, okay, and in the map, at the 0th index, like you will say that the sum 0, initially you will mark it as -1, because what we want to do is, suppose that if you have got if you have got a particular sum, so then you will, like, suppose that you have got the sum as let's say 24, okay, and that sum is occurring in the array, that is fine. But problems will arise now when the sum when the sum becomes 0, okay. Suppose that you take the sum of the array for a particular region and the sum becomes 0, okay, then 0 sum will might not be present already. So then for special cases of 0, we should initially update the map value as -1, indicating that 0 is present at the index -1, indicating that before even starting the traversal, the array had the sum as 0, okay. Okay. Now, after that, what will happen is, in this particular case, let's say you have got this array, right? So what will happen here? Now, when you have the sum, so as I said, first of all, what you will do is you'll update the 0th index with -1 value. Okay. Now, when you come here, you will be at 16. Now, is 16 present because the sum is 16? No. So I'll update this particular sum 16 with the index as what? Let me update the indexing 0, 1, 2, 3, 4, 5, 6, 7. So I'll update this as what? I'll update this as 0. Now, what happens next is my sum becomes 15. The moment my sum becomes 15, I'll update 15 with 1 because it is not repeating. Then after this, what happens? My when I'll check further. So now what will happen? Also, one more thing I need to keep a track. There are two circumstances when my sum can be equal to the length. Suppose that if I have a particular sum till this point and it is equal to I plus 1, because if I am at the ith index now, suppose that if I am at the ith index, then what is the length of the subarray from 0th index till the ith index? It is basically I plus 1. Okay, so this is one more thing that we should keep in mind. So maybe one of the circumstances can be that you're iterating and you are at a particular ith index, and till that point what can happen is the sum might be equal to I plus 1. If the sum is equal to I plus 1 till the ith index, this indicates that the sum is equal to the length of the array. Okay, so this is one more edge case that we should take care of. Now what happens here is, if you will see, so 15 is there. Okay, so with respect to 15, you have updated the index as 1. The next time you will get what? You will get, I guess, 18. You will get the sum as what? I guess you will get the sum as nothing but 18. So you update the sum as 18. And then what you do is, with respect to 18, the index has been updated as 2. Then what will happen? You will get the sum as 11. Very good. Now, once you get the sum as 11, so update the sum as 11 with index 3. Then what you get is you get the sum as 13. Fine, fine with that as well. Now, if you get the sum, let's say, as 13, then also this is fine. So also one more thing, like in this case, you will not only keep on storing the sum. This is with respect to the sum, you will store that at which index you had found it. Now what do you want to check? You want to check that whatever sum I have got, okay, like the thing is, what is the idea behind this? So the idea of this problem, I'm writing this, you can check this also. Idea of the problem, okay, is inspired from Sabare with Kesam. Now, what is the idea for Sabare with Kesam? Okay, so the idea is that, suppose that I'm standing at a particular point. Okay, suppose that I am like, my k value is what? Suppose my k value is, let's say, 10. Okay, let's say my k value is, let's say, 15. Okay, now if my k value is 15, suppose at this point of time my sum is how much? My sum is, let's say, something like 36. Okay, suppose today at this point of time my sum is 36. Now I will check inside the map. What I will check inside the map, does sum minus k exist in the does have I seen sum minus k? Have I ever seen sum as have I ever seen the value sum minus k? That is what? 36 minus 15. What is 36 minus 15? 36 minus 15 is basically 21. So I will check whether I have seen the value 21 already or not. So suppose that if the value 21 is present in the map, okay, if the value 21, if the sum 21 was already stored. So right now, if my sum is 36, then I'll check if sum minus k is present or not. If sum minus k is present now, this means that in between the sum would have been how much? The sum would have been k. That is how you check that subarray with zero sum exists. Is that clear? Sorry, subarray with k sum exists. Is this part clear? Is the inspiration clear? You can write yes or no, guys, in the chat. Are you getting this intuition here? What is the intuition? Basically, what happens is, suppose that as of now my sum is 36. Then I will check whether sum minus k, whether 21 sum exists or not. If 21 sum is existing, now this means that in between I have added the value 15. In between this Sabari sum must be equal to 15 only. Okay, so this is the idea for this question. Dev Priya says that he's not clear. Which part is not clear, Dev Priya? I hope that you get this point, right? So that is why I mentioned some questions which you should be knowing before you could solve such kind of problem. But why minus one was the logic? Basically, why minus one was the logic? Because what happens is, suppose that like whenever you are updating the values, so what might happen is, at some point of time you might get the sum as 0. Now when you get the sum as 0, 0 sum will not be present in the map. Then you will start telling that nothing is repeating. But I'll talk about that concept also in detail. But the main idea here that you have to observe, what is the use of hash map. I'm not checking whether 32 36 is present or not. I'm checking that right now, if my sum is 36, is 36 minus 15, that is 21, present or not. If 21 is present, then I'm very sure that in between my Sabare sum will be 15 only. This is the main logic that I want to want to clear. Why you are finding k sum? No, I am telling inspiration. I am telling the intuition behind the like, if I have to find Sabare with k sum, right? Then what we used to do is, if I have a particular sum right now and sum minus k is present, this tells me that in between the Sabare sum must have been equal to k. This is what I'm telling. Now I want to find what? I want to find, like in this problem, for this particular problem, I want to find that whether or not uh, whether or not I have a Sabare of this much length, what you can say, whether or not I have a Sabare with a given length. So what will happen is, now in it, this problem is also same, because if you will see in this code that I have written, what am I checking? I'm checking sum minus I plus 1. So I'm checking for sum minus I plus 1, whether sum minus I plus 1 is present or not. Earlier, when I had to check Sabare with k sum, I was doing that. Now I'm checking whether sum minus I plus 1 is present or not. If this particular value is present, now this means that in between my Sabare sum that I have, it is equal to the length or the number of elements that I have in that range. Is there any form or trick to solve this Sabare kind of questions? Yes, as I said, you need to have a good understanding of maps. Now let's try and write the test case again so that we can discuss it in detail. Okay, guys. So let's say I have got 16 here. Okay, then I have got what? I've got minus 1 here. Then I've got what? I've got 3 here. Then I've got what? I've got minus 7 again. Then I've got what? I've got 2 here. Okay, then I've got what? 8. Then I've got what? 11. Then I've got 24. I hope you have understood the main intuition, that suppose that if I had like the idea comes from Sabare with k some kind of problem, okay, or maybe similar kind of problems that might exist in the DSA questions, right? Now what happens is, if you have got 0 here, you have got 1 here, you have got 2 here, you have got what? You have got 3 here. Now you have got what? You have got 4 here, you have got 5 here, you have got 6 and 7. These are the indexes that you have. Now initially what you do is, by default you should update the index 0 sum 0 as minus 1, because basically like suppose that at some point of time you want to check whether the sum 0 exists or not. So then you will say that sum 0 never existed, but basically you can indicate that sum 0 is outside the array, like basically at index minus 1. So you might require such kind of circumstances. Can you please justify why your logic work in an example? Yes, I will definitely justify. uh, okay, so justify is a very heavy word. So yes, if you'll see here, now what happens is, you have got the sum. Okay, let's say your sum is 16. Now is my sum equal to index plus 1? No, my sum is not equal to index plus 1. Now what I will do is, I'll update the sum as 16, okay, at the index 0. Also one more thing, what I will check is, I'll check that inside the map. Okay, I'll check that inside the map, do we have what? Inside the map, do we have inside the map, do we have 16 minus 1? Okay, no, 15 is not there inside the map right now, so no worries, we'll move forward. Now after this, what will happen? My sum will become what? It will become 15. Now when my sum becomes 15, then what will happen is, I'll check whether like, is the sum equal to I plus 1? No, it is not equal to I plus 1, because I value is 1, so we are not getting that privilege. Now what you will do is, since you have got 15 here, okay, uh, this need detailed proof. Okay, so yeah, if you will see here, now what will happen is when you have got 15 here. Okay, so like when you have got 15 here, right? So you will check that whether 15 minus I plus 1 is present or not. 15 minus 2 is present or not. So 15 minus 2 is not present. So if it is not present, 15 minus 2, if it is present, what does that mean? Okay, if 15 minus 2 is present, what does that mean, guys? Understand one thing. I am trying to tell you one thing where it's very easy. Okay, do you agree with me that suppose that if I'm asking you one thing right now, if I have a particular sum and some minus k is present, if I check that some minus k is present, this means that in between my sum would be equal to k. Do you agree? This means if today I have this much sum and in the map tells me that some minus k was present, then this means in between my sum would have been equal to k. Now other thing is, in this particular problem, if you have a particular sum so far, okay, and what is present, like if sum minus I plus 1 is present, okay, if this particular value is present inside the map, okay, then this means that you have got your length that you were looking for. Like we'll see this with the help of values. I guess that will be better because you are expecting values based answering. Why check sum minus I plus 1? You will see this. See, now after that, what happens next time, like I'll update the 15 uh, with respect to minus 1 here, okay. Sorry, with respect to the index 1, I'll update 50 uh, 15 with index 1. Then after this, what will happen? I'll get 18 now. Now the moment I get 18, then I'll check, is 18 minus 3 present in the map? Tell me, guys. Now when I'm at 18, okay, so when I'm at 18, okay, I'm at 18 now. If I'm at 18 now, so actually I plus 1 is what? I plus 1 is the actual number of elements that are there so far. So is 18 minus 18 minus I plus 1. I plus 1 is what? Ith index is what right now? Ith index is 2. So is 18 minus 1, that is 18 minus I plus 1, that is 18 minus 3 present? Is 15 present in the map? Yes, it is present in the map. So if 15 is present in the map, what does that indicate? If 15 is present in the map, what does that indicate? So what is Sabare length is not I plus 1. Okay, see, now what will happen is, if you are at this ith index, right? So you are at this particular index right now. Now what happens is, if you are at this index, then your I value is what? Your I value is 2. So if your I value is basically 2 here, so right now you have the sum as 18, fine with that, and your index is what? 2, and I plus 1 value is what? 3. Now you check in the map that is sum minus is the sum minus I plus 1 present? Is sum minus 3 present? Yes, it is present. So this sum minus I plus 1 is present. If sum minus I plus 1 is present, this basically indicates what? If sum minus I plus 1 is present now, then this means that this particular region, this particular part that I have a relation here. Now what is the relation? The relation is that the current ith index that I am at, okay, minus the sum minus the index at which I got 15, okay. If I'll subtract that, so basically the length of the subarray, like you can observe for this particular case, okay, you can observe for this particular case that the length of this particular subarray that is there, no, this this region that is there, this particular region that is there, okay, basically this part is having how much sum? It is having the sum as 2 here, and what is the length of this region? The length of this region is also 2. So this is what I'm trying to say. Okay, is this does this make sense right now or not? You can tell me, guys. Okay, so right now if I have a particular sum and sum minus I plus 1 is present, okay, if I have a particular sum right now and sum minus I plus 1 is present, so this means that in between there is a subarray that exists which is having this much sum, which is having the sum as the length of this subarray, this part, okay. Now when you will proceed further, right, so let's say you'll update what, you will update the index, uh, as what, 18 with the indexing as 2 here. Okay, then after that, what is the next thing that you will do after this particular part is over? Then like the sum will be what, 11. Okay, since the sum is 11, it will like 11 minus 4 will not be present, so at 11 I'll update what, 3. Okay, then my sum will be what, 13. Now when I'll check for 13 minus 5, it will also not be present, so I'll update 13 with the indexing as what, with the indexing as 4 here. Then after that, I'll get what, I'll get the sum as 21 here. Okay, so when I have 21, so I'll update 21 with the index as 5 now. Also, one more thing, when I have got the sum as 21 now, so I'll check whether sum minus I plus 1 is present. 21 minus 6, if it is present or not. Yes, 21 minus 6 is present. Sum minus I plus 1 is present. So this much region is present. Sum minus I plus 1. So if sum minus I plus 1 is present, okay, because I is 5, I plus 1 is what, 6. So sum minus I plus 1 is present for this particular index. If the sum minus I plus 1 is present for this particular index, this indicates that this particular subarray of length this much, okay, this particular subarray of length this much, right, it is having the sum as the length. Okay, this is one observation that you can take off from here. Okay, clear? Does this make sense, guys, or not? Didn't understand what you are doing with the elements that are present. Okay, I'll tell you using the code way. Okay, see, first thing is that normally whenever you are solving such kind of a problem, so you might want to have the zeroth index, zeroth sum also. So initially you'll say that zeroth sum is not it is outside the array. So in order to indicate that, because sometimes in order to take the length now, we want to do what, in order to take the length, we initialize map of 0 with -1. Okay, then you take the sum. Okay, now the very basic case is that if what happens, if the sum, if at the ith index, what happens is, if you're at the ith index and you calculated the sum, and your sum is equal to what, your sum is y is being subtracted from the sum. In order to find, the I plus 1 value is getting subtracted in order to find that whether you have a subarray with the length same as the sum of that particular region in of that particular uh, part. Okay, so if what happens is, if the sum is equal to I plus 1, this basically if the sum value is equal to I plus 1, what does this indicate? If the sum value is equal to I plus 1, this basically indicates that because so far till the ith index, the number of elements are I plus 1. Okay, so if the sum is equal to the number of elements, then in that case you will store this particular end. Otherwise you will try to find for sum minus I plus 1. Suppose that if what happens is, if sum minus I plus 1 is present, if the sum minus I plus 1 is present now, then you will say that the length that you will get for that particular subarray is I minus the index that at which you got that sum. So you can see that whenever you are at a particular ith index, okay, so whenever you are at a particular ith index, if you'll subtract the index at which you got that particular sum, then this is then you'll get that particular length. Okay, does this make sense? Depends how you write it. Basically, since I'm writing sum minus I plus 1 here, right? So that is why the length that you can take is I minus MP of remainder. You can try to do a dry run on various values, but yeah, it is correct. Still you are unsure why we are only checking for sum minus I plus 1. I guess you might have not done the problems where you have sum minus k. Okay, in that case the subarray in that region has the sum as that much. Now what happens is, if you have a particular sum here, and before if sum minus I plus 1 is present, okay, this means what, that this means that let's say in this particular region, okay, the sum is how much, it means that in this particular region I plus 1 sum is there. Okay, this means that in this particular region like kind of you can say that I plus 1 sum is there. Let's just see this, right? What can I say? Let's say if you have got this sum, right? So if you have got what, like, see, observe this, if you have got 21 sum and 15 is present, this means that in between the sub-array sum is how much? In between it is like 10, 13, and then minus this, so it is basically 6 here. Okay, so in between, if it is basically equal to 6, right? In between this much sub-array sum is equal to what? See, in between this much sub-array sum is equal to I plus 1. Okay, in between this much sub-array sum is equal to I plus 1 here. That is that basically indicates that you have found a sub-array which is having the sum equal to the length of the sub-array. Okay, so this is how you'll do it. And if suppose that what happens is, if that remainder, okay, if it is not present, if suppose that this particular sum minus I plus 1 value that you have right now, if it is not present, in fact, instead of storing this right away, what you can do is you can store directly sum minus I plus 1. Okay, you can store this particular index here, and later on, you when you come back, you can check if it is present. So this means that sum with there exists a subarray which has the same sum equal to the length of the subarray. Okay, fine, guys. Still, you have doubts? You can tell me. Okay, right. So you can try to do a dry run. You'll understand the intuition behind it, or maybe if you want, you can read the editorial as well. Right? Not sure how they have given it. Uh, okay, they have given a straightforward editorial, right? Okay, now let's try and move forward to the next question. Okay, when I saw the next question, okay, when you see the next question, so the basic brute force is very clear with respect to the next question. If you'll observe this, so the question goes like this. It is basically minimum difference pair. Okay, the question is minimum difference pair. Now in this question, what happens is in this question, what happens is you will be given an array, okay, and you'll be given another integer x. So you are given an array arr, okay, and you are given an integer x also. Now what you have to do is, the problem is to find the minimum absolute difference of indexes, such that if I take the XOR of two elements, it is less than equal to this. So basically, indirectly, initially you can initialize your minimum as positive infinity, okay, and you have to find two elements. You have to find an ith you have to make sure that there is an ith element and there is a jth element, okay, such that their XOR is less than equal to x. Okay, their XOR is what? Their XOR is less than equal to x, means what? You are trying to minimize your XOR. Okay, you are trying to make sure that the XOR of these two elements is less than equal to x. I'll talk about this, how you minimize it and which problems it reflects to. Then what happens is, if you'll see, the brute force approach will be very simple. Like possibly I can iterate through all the indexes, I and j indexes. I can explore all the j's from I plus 1. Okay, j starts from, let's say, I plus 1, and then j is less than n. Then you can do a j plus plus basically. And once this loop is running, then you can check that if the ith element that you are at, okay, this is the brute force approach, which will take obviously order of n square time, right? Now what happens is, if you have an ith element such that you take the XOR of it with the jth element, and that value is less than equal to x, okay, if you have an ith element and you have a jth element such that its XOR is less than equal to x, then in that case you need to do what? You need to store the length, like basically you need to find the absolute difference. You need to find the minimum absolute difference between the index I and j. So you'll say that minimum will be equal to what? It will be the minimum of the current minimum that you have, comma, j minus I, okay, because j is ahead. So if this criteria satisfies, then you will update this. Now what happens in this particular problem, guys? You have to always you have to always make sure that the distance between the jth index and the ith index, which is following the property, says that arr of I XOR with arr of j is less than equal to x, should always hold. And if you don't find any such pair, then you have to do what? You have to return -1. If you find such a pair, then you have to return the minimum absolute difference between those indexes. Now what happens is, if you will see this question now, So you are trying to do what? You are trying to basically take the XOR. Okay, whenever we have such problems, where we have to take XOR, then trie data structure can be used. Okay, this is another pattern based problem which you can observe. Basically, maybe you can see that there exist certain problems like minimum XOR of two numbers, like minimum XOR of two numbers. Okay, if you'll see on the internet, minimum XOR value in an array. If I'll just try to open this problem here. Okay, so there do exist such problems where you have to do what? Here also you have to kind of get inspired, and you have to try to minimize the XOR of two elements. Okay, because why you have to try to minimize? Because you have to keep it less than equal to x. Here you don't have to maximize it, you have to keep it less than equal to x. So there does exist similar kind of problems, right, where what you have to do is you'll be given an array and you have to find the minimum XOR of any two elements. Okay, so you have to find the minimum XOR. For solving such kind of problems, trie is used, and why it is used I'll tell you. Right, so yeah, is this part clear? Are you getting my point here? Okay, now the thing is that ARR of I XOR with like ARR of j, it should be less than equal to x here. So basically the idea is that you have to try and keep this minimum. Okay, so what you will try to do is, like, whenever you get certain words, okay, you will try to store what? Store the number. Okay, store the binary whenever you'll get numbers here. Okay, once you keep on getting numbers, because you have to solve this problem in almost linear time, right, or maybe close to linear time. So you will do what? Store the numbers. Okay, you will store the numbers in a trie. Now how do we store the numbers in a trie? So what happens is, now let's say if like I can do what? I can make a trie here. Okay, what is trie data structure? Basically, you have two kind of tries that we generally use. One of the tries is for strings, and one of the tries that we use in is for bit manipulation based problems. What happens is, whenever we make a particular node now, so it has a left child and right child. Okay, normally, and left child will basically indicate the bit 0. Okay, if you're going on the left, this means you have a 0 bit. Okay, you're going on the right, this means that you have the bit as 1. Now what happens is, when you have this when you have a number, let's say you have got what? You have got 0 0 0 0 0 32 times, like 31 times 0 and then 1. Okay, so this is the representation of 1 now. So when you will get the number 1, how you will represent it? So you will make a trie node here. Okay, and then you will say what? You will keep on adding the nodes, like you will keep on adding the left children one by one, because if you'll check the bit is 0, if you'll check the bits are 0, so you'll keep on adding the 0. Like what we do is, when we are inserting inside the trie now, we insert the number from left to right. Okay, we insert the number from higher significant bit to lower significant bit. So basically what will happen? 0 0 0, a lot of children will get inserted, and then at last one child will get inserted as 1. Okay, so it will be the right child here. So this is how you'll represent a number. So one by one the numbers will get stored. Now in order to minimize if you want to do what? If you want to if you want to do what? If you want to store if you want to store the elements in a trie, how you will do that? I'll just quickly tell you about this, right? So see what happens is, and there's a similar problem that is maximum for maximum also. Right, now if you'll see here, what you need to do is, you need to declare a trie node. Okay, left and right. Why do we have left and right? Basically you can say that when you have left child, so it kind of indicates for the child 0. When you have right child, it indicates for the bit as 1. Okay, and I am also having a variable max index. It will keep a track of the maximum index. Initially the maximum index will be the index that we are passing. Okay, and then we will do what? We will make a so this is what we have made for a particular node. Now when it comes to the trie data structure, so first of all we'll make a root node. Okay, then after this what you will do is, let's say you have got this array. Okay, suppose that you have got this particular array here. Okay, suppose that if you have got this array, so first of all you will do what? You will declare the root node, the root node of the trie. Okay, or a basic node for the trie, and you will basically put x there. Okay, so initially what you have done is, you have initialized it with the value as x that was given to us. Now what we do is, we initially mark the answer as int max. Okay, initially what we do is, we'll initially mark the answer as int max, because initially we'll assume that our minimum absolute difference is positive infinity. Then initially what you will do is, you initially will say that you are going to insert what? You are going to insert the element. Basically you are going to insert what? Initially you are going to insert the element ARR of 0, and it is present at which index? It is present at the index 0. So this is what we pass whenever we are inserting an element inside the trie now. then whenever we are inserting an element inside the trie, so we insert it, we will do what, we'll put its index, as well as we'll put because we have to put this particular number or the value that we have, the ARR of I, and we'll also keep a track of its index. Okay, so we'll always be putting the index while pushing these elements. Okay, now so initially it is very important that you are putting the very first number. Okay, because for the index 0, okay, for the 0th index, will there be any index before it? Tell me. For the 0th index element, will there be any element before it? No, there will be no element before it in the array. So that is why na, it is very important to insert the 0th element inside the trie. So once you have, suppose that you have inserted the 0th element, so basically the 0th element is 1 here. So you can observe, you can think about it, that there will be a root, a lot of nodes will be there, and then slowly and steadily you can say that, let's say you will have this child as 0, this child for 0, okay, left child, and then after that, let's say you have this child for 0, and then you have this child for 1. Okay, this is what you'll have by default. 1, like you are inserting the 0th element, that is 1 here. Okay, this is something that you have inserted. Let's have a look at the insertion part once again. Okay, so what you have done is, basically while you were inserting, so how do we insert a node? So for inserting a particular value, first you can see that I'm passing the index at which this element is there, and this particular element itself, that is the value is indicating the element itself. Okay, now after this, what you will do is, first of all, you will declare a current, like you will make a current pointer initially standing at the root, and as I said, we will put the higher significant bit first. So we will check, what we will check is whether whether the number that I have currently, whether the element that I have currently, the element that I have currently, whether it is having the ith bit as set or not. Okay, so suppose that if the number has the ith bit as set, okay, if the ith bit is 1, okay, if the ith bit is 1, then from the current node I need a child 1. So if I don't have a child 1, then I'll make a child 1, and I'll say that the index for that child will be the and I'll pass what, I'll also pass the index. Okay, you can see that I'm passing the index. So index will be doing what, index will be storing the index will be storing that which particular node has that index. So basically by default, initially you can see that all these nodes will be storing the index as 0. Why they will be storing the index as 0? Because like you will check if the right if the current number that I'm planning to insert, if the current number that we are planning to insert, if it has what, if it has got the ith bit as set, then I'll check if the ith bit is set. So I need to check for the right child. If the right child does not exist, then I'll make the right child, and initially for that particular child, I'll update the index of this particular element to it. Okay, and then I'll move to, if it is already present, then I will not make it, and whether I make it or not, I will move to that particular next node. Okay, this is what we do in a trie. So prerequisite is that you should be knowing about the trie data structure. Now suppose that otherwise, what happens is, otherwise if the bit was not set, then I'll check that if the bit is not set, then this means that the bit is 0. So I need to go on the left. So if the left child for the current node that I'm at, if the left child does not exist, then I'll make the left child, and I'll say that the index for that node will be updated with respect to the index of this element. Okay, and whether it exists or not, if it does not exist, I'll make it. If it exists, then that's fine, and we'll move to that particular left node that we have made. Okay, and at the end, what we after this part is done, right? So for every current index that I'm at, okay, for every current index that I move to, okay, suppose that if it might already exist or it might not, so I'll always update it with the maximum index value. Okay, I'll always update it with the maximum index value. So whichever path I'm traversing inside the trie, okay, whichever path I'm going to traverse inside the trie, I will make sure that if there is a higher index, if there's an element which had an higher index, so I'll say that that node is, because that node should indicate the higher index of the array. Okay, that is what we are doing here. Is this much part clear? If this basically, guys, again, this contest was easy for those people who already had some pre-knowledge, prerequisite or prerequisites were fulfilled from for them. Okay, if you know hashing very well, if you know trie data structure very well, then you can do it. But otherwise, if you have not coded these problems, that is why I'm saying, I'm not boasting or doing anything, right? That is why I'm saying that if you have not solved such kind of a problem, because I'm not sure, but if you'll see my code here, I must have written some code for it. Okay, I'll show you my own ID. Okay, so you can see here, if I'll open this problem here, I must have solved it. before. Okay, so you can see here that if I'll open my submissions here, right, you will see that I have submitted this problem. Okay, and and in this particular case you can see that I also did almost the same thing. And initially you can see that I took the minimum as int max, and then I inserted the 0th element. Okay, so this kind of problem, if you have not done this kind of problem now, it will be difficult for you to solve such problems. And this problem, that the relevant problem that I'm saying for this, right, minimum zor value pair. Okay, almost kind of at least structurally very similar. This problem has been asked in Microsoft. So if you don't have prerequisite knowledge of such problems, then obviously these problems will look alien to you, and you will feel that I'm just boasting about these problems. But if you will not solve such problems now, if you have not solved problems of try that are based on strings and that are based on zor approaches, then it is difficult to deal then it is difficult to implement such kind of a problem directly. Okay, is that clear? So make sure that even after this lecture is over, you are definitely learning tries, and you're implementing zor based problems of try as well as string based problems of tries. Okay, so yeah, this is how the insertion process will work. Now once the insertion processes work, okay. Right, so yeah, now after this what will happen is, then now you have got what, like you will say that you will whenever you are at a particular element. Okay, so you will try to find okay, you will try to do what, you will try to find the like you will write a search function or a find function. Okay, this function is going to do what, in this function you are passing the ith index, and you are passing the uh, ith element of the array. Okay, and it will give you a result. Okay, it will give you a result in the which will be basically indicating the it will give you a index which will give the distance of the ith element and the element with which it has the zor. Okay, and if this distance is lesser, then in that case what you will do is you'll update it in your answer, and then after this only you'll put the ith element. Why we are not putting the ith element before? Because if you put the ith element before, zor of the ith element with itself would be 0. So that is why now, first of all, we are doing what, we are processing the ith element with respect to whatever elements are there before, and then only after that what we are doing is we are updating with whatever resultant distance that we get. Now how does the find function work? Again, it is again you will deal with the opposite things here. Okay, so suppose that initially you have the index of the element that you are at, and you have the value that is the element itself. Okay, then what you will do is you will update your current with respect to this particular root, and initially you can mark your answer, let's say, as int max. Okay, then after that what you can do is you can start iterating from the highest value significant bit. Okay, then you will check, what you will check is you will check this part, that if since you have got x here. Okay, so you have got two things. See, you have got x and you have got the element. So you will check what, you will check that inside the x, like the x is the variable that was given. So I am given which kind of target. I am basically asked to do what, I'm basically asked that I have to find two elements, right? So as that their zor is what, their zor is less than equal to x. So this particular x that we are referring here, it is the given x. Okay, so I'll check inside x if this bit is set. Okay, inside x if this particular bit is set, then I'll check what, if this bit is set inside x. Okay, then I will check that if this same ith bit is set in the element that I am currently having in the array also. If it is set, then we will do what, then we will move to the right side. Okay, if it is set, then we will say, like if it is set, then you will say that in the current element also, if it is set in the ith element and it is set in the current element also, then we'll try to do what, we'll try to check that if in the x, in the number that I have, if the number x is there, if it has the ith bit as 1, and the current element that I'm at, if it is also having the ith bit as 1, then I'll directly move on to the right child. Why I will move on to the right child? The reason is because if this bit is set in x as well as in this element, then I can directly move on to it, and I will keep it like I will do what, I will say that my answer will be what, it will be minimum of the current index minus the maximum index that is stored for this particular current node. Okay, otherwise if the left child exists, then I'll move to my left child. Okay, otherwise what you will do is, otherwise suppose that if the bit was set in the number as well as uh, in the number x as well as in the element, and left child or right child did not exist, in that case what you need to do is you can directly return the answer, the minimum answer that you have got so far. Okay. And similarly, so maybe basically you can understand that many of the times it will be positive infinity only. Otherwise, if suppose that the bit is not set, okay, if the bit is not set, then you will try to go to the left child if it exists. If it does not exist, you will try to go to the right child. So you'll, when you try to go to the left child, so left, because the bit is set, if the bit is set in x as well as in the number, then you'll go on that path. And if you're going on that left path now, then you will say that whatever index you have minus the current left node that I'm at, its maximum index. Okay, so that I can always do what, so that I can always uh, keep a track of the minimum answer. Okay. And so we'll check that whether or not in the number whether that bit is set or not. And otherwise, suppose that if in the x it is, if in the x variable it is not set, so if in the x variable the bit is not set and in the element that I currently have if it is set, then I'll directly say that let's move to that element. Okay. And otherwise, suppose that if the bit is not set in the element as well, then I'll move to the left child. So very simple and straightforward approach. uh, can't you use two pointer approach here? If you want, you can use two pointer kind of approaches here as well. But the problem, like you can use map also, you can use lower bound and upper bound functions also. But if the test cases are hard, so they might start giving you wrong answers, or they might start giving TLEs also. So that is one problem. Okay. Now talking about this, so again, once you end, so if the current node exists, then you will take the minimum of the index minus the current max index. So you will always keep a track, like you will always try to do what, you will always try to check for that number, like you will always try to check for the criteria that the zor that the zor that I am having, right, it is the minimum. Like if you have same bits now, then they will cancel out each other, so the number will become less. So that is an advantage for you, because you have to make sure that the zor of the two numbers is less than equal to x. Okay. So that is why we are iterating like this, because we don't like we have the element also, we have the x also, and then for the other element we are traversing on this trie here. I am looking at your messages only. I'm looking at the YouTube chat only, right? Okay, let's move forward now. Okay. So yeah, this is one thing that you will do. Relevant problem that you can solve is minimum zor pair. Okay. So maybe minimum zor value pair. If you will solve this particular problem, then the intuition for minimum difference pair will become more simple. Okay. Because this minimum zor value pair that was asked in Microsoft, it is much easier compared to this. Okay. So you understood what you have to do here, guys? If yes, then we can proceed further. Okay. So yes, let's try and proceed further now, and let's see this problem. How many of you were able to do the last problem, guys? And again, in this problem, there are a lot of possible ways, right? In this problem, the thing is that there are a lot of possibilities that you need to generate. That is why we use the recursive approach for this problem. See, what does the problem say? Problem's name is basically number of expressions. Okay. Now, got TLE. TLE, in which problem you got TLE, Vinita? Like for this number of expression problem, or which problem? For which problem did you get TLE? Okay. So yes, if you will see here, number of expressions. Okay. So yeah, if you'll see here, it says that you will be given an array. Okay, and the array's length is what? It is n. Now, what is the other information given to us? The other information is that there are x plus and y minus symbol. Okay, so you have got you need premium membership. Why? What? Like, I'll just do one thing. Give me a sec. Okay, so yeah, see, you have got what, you have got plus symbols here and you have got minus symbols here. Okay, so you can use, basically the problem tries to say that you can use plus symbols and minus symbols. Okay, you have got x number of plus symbol and you have got y number of minus symbol. Okay, and you have got an integer target. So you need to do what, you need to build an expression by adding plus or minus, such that before each integer you are applying like before each integer you are applying certain kind of expression, and you have to tell the number of expression that will be there. Okay, which will be having what, you have to tell that how many expressions are there, like how many ways you can make expressions such that they will be equal to the target. For example, if you have got what, if you have got this array, so again the problem will be done how, like the problem will be done using many possible ways. Like you have to try all possible ways for this problem. Okay, when you have to try all possible ways for this problem, so basically this indicates that this problem will be solved with the help of recursion. Okay, whenever you have to generate, whenever you have to generate all possible ways in a problem, all possibilities, okay, all possibilities are generated using the recursive way. So that is why like recursion is used here. So if you will see here, like in fact there is one problem which I'm not I don't remember the name of that problem, but there is a very similar problem where for every element you need to apply plus or minus sign to it. So if I knew about if I remember that problem, I'll just try to show you. But there's one problem that is tagged on GFG with this particular tag. If you would have solved that problem, maybe this problem might have been easier. Okay, so what happens is, see, in this particular problem the thing is that you'll be given plus and minus, and you have to tell that how many combinations will be there, so that you are able to make the make that particular make the combination, okay, which is equal to the target. So if you have got what, one, then one, okay, then after this you have got what, you have got one again, then you have got what, you have got one, and then you have got one here. Now after this what will happen, you have got the x value as what, 4 here. Now the y value is what, 1. So you have got 4 plus signs, I guess, okay, and then one minus sign. So how can we do it? How many ways are there? So possibly what I could have done is, I can say that I can add plus 1 plus 1 plus 1 plus 1 and then minus 1. And this is one such expression which is giving me the sum as the target, because my target here is what? The target here is 3. So before, for every element that you are at now, maybe you can try to apply plus or minus to it. That is the main intuition that you can keep in mind here. Does this make a bit of sense so far or not, guys? You can tell me. Okay, so what happens here is, like if you will see how we are going to solve this particular problem. Okay, so like we'll make two arrays here. Now what is the use of these two arrays? So basically you will make first array as first like you will do what, you will try to segregate the elements. Okay, the elements that are less than n by 2, the first half of the array you will try to put in the first array, and the second half of the array you will try to put in the second array. Then after this what you can do is, you can take two maps. Okay, now what you will do is, like what you will try to do is, initially you will try to call the find ways function. Okay, so basically this function is going to do what, this function is going to find the total number of ways for you for the first half and the second half. Now once you run this function, so how will it work? Okay, so basically what you will do is, when you are running, so once you start, so initially you'll start from which index of the array? You'll start from the 0th index of the given array that we are passing. Okay, and suppose what happens is, if you're applying your process, so what can happen, right? In one step what can you do? If you are at a particular index, then you can say that you can move to the next index. Okay, and either you can take the element as plus or minus. Do you agree? See, the ith like the ith element that you are at, okay, the current index that you are at, either you can take it as positive or negative. If you are taking it as positive, then you can say that you are taking one plus sign. So you will do what, you will say that you will do map like plus like you will increase the value of plus, and minuses will remain the same, and you'll pass it. And otherwise what you are doing is, guys, otherwise if you are taking the current element as negative, So in that case, you will say that you have taken one minus, so you'll increase the value of minus here, and then you'll pass on the next index. So by doing this, what will happen? All the possible combinations will be made, and once you reach the end point, then what we are doing is, once we reach the end point, then we have made a pair. Okay, what pair we have made? We have made the pair that what is the sum that we got. Okay, we, like, in order to make our task easier, we have done what? We have made a pair that what is the sum that we got, and how many pluses and minuses were required for that. So we are counting such kind of such unique pairs. Okay, and once you have counted this, so basically by doing this, now you are generating all possible ways. See, first of all, you are passing the first half of the array and the second half of the array, and you've got two different arrays. Okay, by passing the arrays, what we are trying to generate is, understand one thing very clearly. By passing the like first array and the second array, which consists of the first half and the second half of the original array, what we are trying to do is, we are trying to say that, suppose if I was at a particular element, and if I took it as positive, or if I took it as negative, then my sum would be some plus arr of index, or some minus arr of index. Okay, so we'll keep on doing that, and once we reach the end points now, then we'll see that what is the sum that we are able to generate, and how many plus signs were used for that, and how many minus signs were used for that. So this is something that will help us in the counting later on. Now after that, what will happen is, when you'll iterate, so you'll iterate through the first map. Now the first map is indicating what? Basically the first map is indicating the combinations that we got for the first half of the array. Okay, now once you get those combinations, right, so you have already got the excess. Now what you will do is, you will see that if you are at a particular map, okay, if you have a particular sum, so basically what is the required sum? Because for every pair, what you have got inside the map, like, you have got the sum inside the map one, you have got the sum, and how many plus signs you have used, and how many minus signs you have used. Okay, this is what you have. Correct. Now I dot first is going to indicate what? Okay, so yeah, I dot first will indicate what? I dot first will indicate the sum. I dot second dot first will indicate what? It will indicate the plus sign, and I dot second dot second will indicate what? It will indicate the minus signs. Now once you have this, so what is the required sum? Because the thing is that you want a target sum. Okay, so you will check what? You will check that the first half the first half that has ran. Okay, how much sum it was able to generate? You will check that the first half that ran now, how much sum is it was able to generate. The required sum is this much now. Okay, so this is the required sum that I have, and how much is the require, like, how many required x value I want from the second pair. So if I have x, okay, so I have used I dot first dot second dot first. So basically this basically indicates the number of x that have been used by you. Okay, so total number of x minus the number of x that have been used in the map one in order to make the combination. So required number of x would be this. Required number of y will be what? The value of y minus the number of y's that you have used. Okay, so then you will check that if such a pair exists in the second array. Okay, so whatever number of times such a pair exists, that many combinations you will multiply. Basically you will say that whatever is the frequency, whatever is the number of times you have this pair in this particular configuration inside the first map, and whatever number of times you have this particular configuration in the second map, that many times your answer will get updated. So that many different combinations you'll have. So this is something that we are doing here. Okay, so is that clear? Yes, yes. You need to store some minus I plus one. I just did a slip of tongue because I was explaining for sub array with k sum na, so that is why I did a slip of tongue and I told you that you will store some. Okay, so I hope that this question makes sense. How we are cleverly doing it. So you are basically you are trying to do what? You are trying to break the array into two different arrays. Now why we are breaking the array into two different arrays? Because if you will see here, the thing is, if you will see here, no, the thing is that right now, if you have got the array size as 30, okay, if you have got the array size as 30, if you have got the array size as 30 for one element now, if you will put two choices for one element, you have got two choices, right? Either you take positive or negative. If you do it as a whole, then it will be very high. It will be 2 to the power 30. So in order to reduce that complexity and make the calculations easier, right, we are segregating them into two arrays of 15 element maximum. Okay, so is this question also clear? The idea for this question is clear, and what we are doing here, whatever sum you reached, how many pluses you required, how many minuses you required, you are keeping a track of that here. Okay. So, was this question also clear? I felt that this question was tough because you had to keep a track of pairs. Otherwise, it would have been easier if they would have made the constraints a bit easier, and maybe they would have just asked for the counter in a easier fashion. Then this question would have required less effort. But yeah, this is a very good question as well. Okay, so you can try this out. So I hope that you have understood the idea and the intuition for all the four problems. The first problem was very easy. For the second problem, you need to know a bit of hashing. For the third problem, it was a hard problem because you needed to know tries for it. For the fourth problem, it was hard because we not only you need to require knowledge of recursion, because you need to apply all possible ways, but also in order to make your answer easily feasible, you are breaking the array into two parts, the first half and the second half, and then you are deciding that how many pairs you'll get by generating all the combinations of sum and plus minus for the first and the second half of the array, and then iterating on the first map and checking correspondingly in the second map that if the first map you have a particular sum, then remaining sum is this much, then remaining number of x is there, and remaining number of y's that you expect from the second. And if such a pair exists, then whatever number of times the first configuration exists in the first array in the first map, and the second configuration exists in the second map, that many combinations you'll have, so you will return that pair at the end. Okay, so I hope you understood the idea and the intuition for this, guys. In case if you still have any doubts, okay, regarding these questions, so definitely you can ask them in the comment section, or you can DM me, I'll try to answer them. But yes, you can also keep the discussion alive in the comment section is available for you. So definitely you can try to discuss the problems in the comment sections with other peers as well, so that you can look at their approaches, and you can also definitely check out the editorials, because we have the editorials uploaded as well. Okay, so I hope that you understood the intuitions behind the problems. Doing the dry run for all the problems is very difficult, because the second problem itself will take a lot of test cases to do the dry run. Third problem is a try problem, so making tries for a very big example of 32 each is difficult. And number of expressions, this problem is also conceptual in nature rather than dry run. Okay. Okay, so yeah, thank you guys, and I hope that you understood everything clearly, and all the best for the future contest, and thanks for joining. Thank you guys.